Hi, good day. We've now come to lecture 3, which has to do with surface vector analysis for Africa and Europe. This surface vector analysis involves the wind, because wind is a vector quantity which has magnitude and direction. However, we'll be dealing more with the direction of the wind, the analysis of the direction. We're already through with the scalar analysis in lectures 1 and 2. We are now in vector analysis, concentrating on the streamline for Africa and Europe. And this is the map of Africa and Europe, taken on the 27th of February 2013 at 1200 GMT. This is a surface map. We are still at surface. We have not gone at upper level. This surface map. Looking at this map has already been analyzed to make things easier and just to guide how this has been analyzed. This map, however, is of low resolution. That is why we can see the various stations. They are very tiny, and then the wind codes, how the winds have been coded, are also very tiny. We can't see. So we decided to crop this map. And based on the procedure of analysis, we look at areas where data are dense, and that is the North Africa and Europe. So we have to crop this map to show only North Africa and Europe and get it enhanced. And then this is what we have. That's the enhanced map of North Africa and Europe. Well, looking at the map, we see stations now more clearly. We can see, look at my cursor, look at the wind here. The wind here is indicated by a straight line and another line branching out like that. This one again indicated by a straight line and branching out. And for easy understanding, I decided to show these codes for the wind, direction and speed. Now this one here is a straight line like that, and then there's a branch out like that here, a very small branch, not from the tip, but from a little bit away from the tip. So that little branch shows the value of 5 knots, and while that straight line shows the direction. And the direction is usually considered where we have the branching of the wind value. So we look at the direction as coming from here, that is from the eastern side, going to the western side. So this direction is an easterly, that is wind flowing from east to the west. The same thing is for this, flowing from east to west. But this time around, the branch is longer than this and at the tip, and it is 10 knots. The third one, the branch is longer. We have the longer one and the short one, and it's then 15 knots. And this is 2 equal branching out from the direction, which is 20 knots. If the position of the wind speed is changed, then the direction will be, for example, if this is now on this side, if these 2 branches indicating the wind force is on this side, then the direction is from west to east. Now coming to the analysis, we look at this station. We see the wind up there. The direction is coming from this side down, that is southwards. It's around northwest and going to south or southeast, and that is this. So we take the direction parallel like that. But before we leave the station, we see another wind here. The direction is from around the southwest and is going towards northeast. So as we come here, we have to turn around in respect of this to keep it this way and put the arrow like that. And this one is also like that. We take it down and then we turn around, because the wind here tells us it's from around southwest and going towards northeast. So we turn it around like that and put the arrow. Likewise this, we take it there. Looking at the wind force here, the wind force here is about 35 knots. 35 knots, but we're not looking at the wind force, we're looking at the direction. So we just take it parallel, passing the station, and then here we see this one again, so we curve it, take it parallel to this, and it now joins this one. The same with this one that branches out from here, taking down south, parallel to this wind at this station, and then we turn it around like that. This one as well. In fact, this one starts from here. We take it from here because the wind shows the direction here is from west to east. So we take it this way and take it this way, and then put the arrow, continue, and then following how the wind bends, and then the southwards, and then it joins here, and then up to there. So all these winds that are joining like that are what we call asymptote of convergence. It's what we call the winds joining the main one in this direction is called asymptote of convergence. This one again is taken like that, and it goes down and descending over there. And here is also taken here, it branches because there's a wind in this telling us that wind is flowing this way. We take it down like that, and over there it branches to this side, and the arrow is given. Here again, there's another wind here. We have to branch this out in respect of another wind that is there to that side. Now this one again, we start from this way. We take it this way, following the direction of the wind, and the wind is showing it has to go like that. Then at this point, there's a wind that tells us is going slightly away from the south, going towards the south. Another one tells us it's going towards the east. So there's a branch this way and that way. This one branches like that and continues up to that point. Now this one, look at this, the winds are all branching around south towards southwest. This one, so it branches from this one down this way. This one branches southwards that way and branches like that, and like that. So as long as we see the wind turning around, we follow the turning of the wind. Here we have to turn this way, turn like that, take it down south. Then as we get towards here, there's a wind that is telling us the westerly, about nearly southwesterly wind. Then we turn it that way, and then here it turns around again, and so forth. Then here again we see this one is turning clockwise. It's clockwise, and when winds are turning clockwise, at the center we label, when it almost closed, at the center we label A, and that A refers to anticyclone. So flows that are clockwise are called anticyclone, while flows that are anti-clockwise, that is anti-clockwise, are called cyclone. We are coming to that. This one flows like this and like that. We come to a position where we have the neutral point. This is a neutral point. We think branches this way, branches that way, and over here it branches this way and that way. So the wind really comes in like that and then goes out like that. So this turning is also clockwise turning, and this is A, anticyclone, and the thing continues down like that. We continue following the direction of the wind. We don't go against the wind. We follow the direction of the wind down south. Then this same thing there. We do this and so forth down there. This one is taken down like the southwards like that and turns. And then this is now anti-cyclone, which is clockwise. Then the others, this one now is a cyclone because the flow is anti-clockwise. You see it? Anti-clockwise. So that's a cyclone. It's labeled C. This is another one that we take it down like that and this way. Now this one again, we take it this way down and then down like that and then like that. And then this one again that branched here, we take it as following the wind, how the wind curves, we follow it and then turn and then like that and put all the arrows. So the same thing there. We continue like that until we get all of them done. That's how this has been analyzed. And therefore, at this moment, I will be stopping this lecture. Next time, we'll look at Africa and West Africa and North Africa. Thank you.